Statistical Rethinking, second edition, chapter 14. We're in the hard problems, question 14H3. Make sure that if you're going to run any of this code that you've used the top blocks here to install and load the Rethinking package. And here we go. Okay, so this is a further continuation from 14H2. So we've looked at this data set in 14H1, 14H2, and now again in 14H3. What we are going to, well, let me tell you what we did in 14H2. In 14H2, we built a model in which we were trying to understand contraception use among women in Bangladesh, I guess. And during that, we used as predictor variables the district that they were located and whether the area that they lived in within that district was urban, the woman's age, the number of children she had, as well as this interaction term here, age by children. And now what we're asked to do is to change the children variable and change how the model interacts with children from being a, well, in this one we made it a standardized normal variable, okay, so a continuous variable even though it's an integer. But now we're asked to change it, to change the model to interact with children such that children are treated as an ordered categorical variable, right? So we have the category of one child, the category of two children, and I think that the most that there are in this data set is 4 children. So we have 1, 2, 3, or 4 children. And so we're going to treat that as an ordered categorical variable. Well, I guess that's what we're going to do. So first thing we need to do is to bring up the data set, and I just call it D, as is done throughout the book. The first thing we need to do is to adjust the data from what we had in the previous problems here, okay? So now children just gets entered as a number, as the integer 1, 2, 3, or 4, okay? And then we are going to need, so going from 1 child to 2 child, 2 to 3, 3 to 4, there's those different cut points, I guess is what they were called earlier, or in an earlier chapter. And we need a prior for each of those cut points. And so those were called alpha. And so there's, how many cut points are there? Well, there's 3. It's the max number of children minus 1, right? Because to go from 1 to 2, 2 to 3, 3 to 4, well, that's 3 cut points. Okay. So now we go to set up the model. And so here's our linear part. So all of this is the same. And it's just where we had children that things differ here, okay? So, so instead of multiplying the beta children and the interaction term by, number of children, we're going to be multiplying it by this guy right here, this monstrosity right here, okay? So what is, so we're going to take the sum of this new parameter k, where there's a new k for 1 through however many kids. Okay, that's what I chose k for, kids, number of kids. Okay, so now then we need to define k, and so the way that we do that is we come down here, we make a vector, right? There's going to be 4. There's going to be 4 k's, right? Then the number of categories. Okay, so vector, and then this is just a number, max children, which I defined here in the data list, max number of living children. Okay, so there's 4. Okay, and then we just use this code right here, which is just taken from the book. Okay, and then we need to okay, so it's kind of hard to talk through this code, but we need to kind of define the limits of k as we go along here. And so we need this parameter delta. Okay, and so we need to set a parameter here for delta, and it's the sum of all of the k's need to add to 1, and so delta is a simplex, and so we apply the Dirichlet prior to it. And then what is the prior for each of the deltas? Well, it's what we defined earlier, alpha. Okay, so we run this. It's already been ran, and then I call up the Pricey outputs. Okay, and so this is just the depth equals 1, right? So these are the same outputs as what we got in 14H2 up here. And the outputs are, so if you compare them, they're directionally very similar, except for age. Age has gone from being pretty positively negative here to being fairly ambivalent here. I'm not really sure what accounts for that. Maybe if I thought about it for a little bit longer, I could come up with an explanation, but I'm not really sure. But really what we're curious about here is the effect of the number of children, right? And so then we want to call the Pricey output for delta, right? So these delta parameters are in depth 3 of the Pricey output, and we want the delta 1, okay? So we see that delta 1 is bigger than delta 2 is bigger than delta 3, roughly. I mean, delta 2 and delta 3 are pretty similar, but delta 1 is far and away the biggest. So what does this mean? So what does delta mean? So delta 1 is going from having 1 child to having 2 children. And delta 2 is going from 2 children to 3, and delta 3 is going from 3 to 4. And so the size of delta 1, maybe compared to delta 2 and delta 3, says that once you've had 2 children, going from 1 child to 2 children, has a larger effect on using contraception than going from 2 to 3 or from 3 to 4. Okay, so that's how we read this. So, so as I was doing this, I realized it would be kind of interesting to know what delta naught would be, you know, going from 0 to 1. But that's not in the data set here. But okay, so hope this was helpful. Yeah, so this is really just the mechanics of the ordered categorical models, which were learned about in a previous chapter, just applied here.